Okay, so here's the notes for 2.1. A lot of this will be review, especially if we look at goal 1, utilize many properties of linear equations. We're going to look at their algebraic and graphical representations depending on what information we get or we have and what we want to get. We will use the different types of forms and properties we have for them. And the second part is determining equations of circles in standard form. And part of what you'll be doing with that is going to involve the distance and midpoint formula. So those of you who have not taken geometry may be at a little disadvantage, but we're certainly going to work through it. Okay, so for goal 1, which is utilize many of the properties of linear equations, and as it says there, this relates to your homework on page 183. That we have some very important forms, which we'll talk about all the forms, and then we will go into the examples. So first one, slope for intercept form y equals mx plus b. Unfortunately, given this is a lesson on a day of the sub, I don't have the time to go into why that works in terms of representing an object that moves in a linear fashion, whether if we're talking about the relationship of two things like number of students in college over so many years or whatever it may be, increasing, decrease, and so on. That is the form. M being the slope, which algebraically, meaning if we're given 2 points like x1, x2, or x1, y1, and x2, y2, the slope for that would be the difference of the y's divided by the difference of the x's. So for instance, if I have the coordinate 2, 3, and I have the coordinate 4, 5, you can interchange those. It really doesn't matter which one's x1, y1, and which one's x2, y2. If you plug in the formula correctly, they'll give you the slope of the line, which tells you the slant of the line when we graph it. Graphically, we think of slope in terms of the rise over the run. The rise is the change in the y values, just as it is algebraically, divided by the run, the change in the x's. So rise when it's positive means we're going up, and rise when it's negative means we're going down. The run when it's positive, since we're talking about the x value, moves right, and the run when it's a negative number, we move left. For this form up here, m again is the slope, but when we're talking about the y-intercept, it is b. The y-intercept equals b. A point is 0, b. Why is it 0? Because the y-intercept x always equals 0. So in terms of getting slope-intercept form, the two pieces of information we need to know is the slope and the y-intercept. So slope-intercept form at the end, let's say if our slope is 2 and our y-intercept is -3, that would be our general linear equation. As we move down to standard form is just another way of representing a linear equation, but is in the form ax plus by equals c, where a, b, and c are all integers. A typically is positive, but I am fine with keeping it negative. So an example in standard form would be 2x minus 4y equals 10. That would be a standard form. Now, this doesn't tell us really anything graphically. It is just a useful form, for instance, when we're solving systems. We solve by elimination when both the equations are in standard form, and it works in other capacities as well. Note, if we have something like 1/4 x minus 2y equals 15, we want to get all integers, which means we have to get rid of the fraction, so we multiply by 4, and then we get 1/4 times 4 is 1, 4 times -2 is -8y, and then 4 times 50 would give us 60, so that's supposed to be an 8 right there. In any case, we have x minus 8y equals 60 would be the standard form for that. Next, horizontal lines. Horizontal lines are obviously horizontal, and it says if it goes through the coordinate of x comma a, then the equation of the line is y equals a. So let's demonstrate that. If we have the coordinate 2, 3, the x value of this coordinate is 2, the y value, which I'm representing as a, is 3. If we graph that coordinate, let's go over to the graph. If we graph the coordinate 2, 3, go over 2 and up 3 would be right here. Again, we go over 2 for x and then up 3 for y. And then if we draw a horizontal line through that, I'll draw it as best as possible. If we look at every single point on that line, if I pick this one, for instance, that would be the coordinate 5, 3, This one would be 2, 3. If we picked all these other coordinates and looked at it, looked at the coordinates, what do we notice about the x values are changing, but the y values are all 3. That is why we say that the equation is y equals the a value, or y equals whatever the y value is of the coordinate. Therefore, for this, if a line goes through 2, 3, the equation of the line is 2, 3. Or excuse me, the equation of the line is y equals 3. Now, let's look at the slope of this line. Remember, graphically, slope is rise over run. So what we do is we take 2 points on the line, any 2 points, and we look at, to get from one point to the next, how far do we rise and how far do we run. If I go from this point to this point, ask yourself, how far do you go up or down to get to that point? Well, we don't go up or down at all. Therefore, the slope of the line, m, the rise, which is the numerator, would be 0 because we did not go up or down at all to go from that point to that point. Now, to go to that point, we run 3. We ran 3 to the right. And 0 divided by 3 is simply 0. Now, it didn't matter what point I picked, any 2 points. If I took this point and I took that point, my rise would still be 0 and my run would be -4, for instance, in this case. But it doesn't matter because 0 over anything, provided it's not 0, equals 0. So the slopes of horizontal lines, the slope of a horizontal line is always 0. Vertical lines would be a vertical line, obviously, through a given point. And in this case, we're saying if we label the point a comma y, the equation of line is x equals a. Well, why is that true? Well, let's take the let's use a different value other than 3. Let's look at the coordinate 5, comma, -1. If I take the coordinate 5, comma, -1 and I graph it, 5, 1, 2, 3, 4, 5, down, 5, -1 would be right there. And if I drew a vertical line accurately, I didn't draw that very accurately, but if I drew it accurately, and we looked at every single point on this line, for instance, this looks like what, 1, 2, 3, 4, 5, that looks like 5, comma 5. Up here we have 5, comma 8. Down here we have 5, comma, -1. In all of these cases, we notice that the x value equals 5. So, for this point right here, if they said through this point, what is the vertical line? It would be x equals 5, the x value of the coordinate. Now let's go back over here and look, what do we do for slope? Or what is the slope of a vertical line? So, we want to do the rise over run again. So if I go from, and remember, we can select any 2 points on the line. If we do it correctly, it will give us a slope in either case. If I go from here to here, I am rising some value. I think it's, what, 6? Yes. I'm rising 6. And then how far are you running? If I go from here to here, I rise 6, but I do not run to the left or right at all in order to get to the coordinate. Therefore, the run is 0. 6 over 0, as we know, is undefined. Mathematically, the slope of a line, a vertical line, is always undefined. So if they give you information that the slope is undefined, we know we're talking about a vertical line. This says parallel lines, 2 different lines, their slopes are equal, but their y-intercepts are the same. So let's say if I have a graph here. Let's say if I have a y-intercept of 3 and a slope of 2 for a line, and I draw a line. Of course, if I drew it accurately, that's not completely accurate. But in any case, that's a line with a slope of 2 and a y-intercept of 3. What if I have a y-intercept of -1 and a slope of 2? If we look at these, those lines do not intersect, provided we're on flat space. Okay, the slope of the black line was 2 over 1, and the slope of the red line was 2 over 1, and we note that they are parallel. Now, if you look, their y-intercepts are different. However, this is the most important point. The fact that their slopes are the same, though their y-intercepts are different. The slopes are the same is the most important part. If their slopes are the same, then this red line would not go through -1, it would go through 3, and the line would be exactly the same. So, the most important part for parallel lines is that their slopes are equal, and we'll see how that applies when we work on it in the examples.
Okay, now that we've dealt with parallel lines, now let's look at perpendicular lines. This says that the lines that are perpendicular have what are called opposite reciprocal slopes, meaning if you take a slope of 2 and then take the opposite, which would be -2 and flipped it, -1/2, that would be the slope of the line. In another example, 2/3, -3/2, that would be the opposite and the reciprocal of that slope. It also says that the y-intercepts can be the same or different. Now, what's important for perpendicular lines is the slope, not particularly the y-intercept. So let's look at an example graphically of two lines that are perpendicular. Now, I'm not going to be 100% accurate with this, as I'm fallible. I'm not going to be perfect drawing this, but we'll get an idea of why they are opposite reciprocals of each other. So let's take a nice, easy one. Let's go with a y-intercept of 1 and a slope of 2, up 1 or up 2 over 1. So if I graph that line, I'm going to do it as accurately as possible. Not the best, but again, we'll get a good idea of what we're talking about. Now, if I try to graph a line that is perpendicular to that, it's going to look something like that. That's about perpendicular. And now if I choose 2 points, this one and this one, again, this is not completely accurate, but hopefully we're going to get the idea. If I do the slope between those 2 points, up 1, rise of 1, and over -2, again, the slope of the black line, is m equals 2. The slope of the red line was -1/2. If you look, those are opposite reciprocals of each other. Now, in terms of the y-intercept, this red line, this has a y-intercept there, that has a y-intercept there. We could take that and scoot it down, keep it perpendicular to the black line, and have the same y-intercept. So we'll see algebraically as we look at perpendicular lines, we look at the opposite reciprocal slope. So just to sum up, for perpendicular lines, the important part is the opposite reciprocal slopes, and we'll see what happens when we have some algebraically. Okay, so now after we have all this information, we're going to have to use it effectively. For number 1, it says find the slope, y-intercept, and graph of 3x minus 8y equals 16. Well, this is a linear equation, and it's in standard form, ax plus by equals c. Well, if we want to find the slope and the y-intercept and then graph it, it helps to be in y equals mx plus b form. So we are going to solve for y. 3x minus 8y equals 16. So now in terms of solving, we're going to solve for y. So think of y as your variable. We're going to subtract 3x from both sides. And now we have -8y equals, note, we want an mx plus b form. We want to write the x term first, so we have -3x plus 16. And now we want to solve for y, so we divide by -8. We divide everything over here by -8. Since we want 2 terms, I decided to break it up. We now have y equals 3/8 x minus 2. Our slope, since they asked us to find slope, is 3/8, so we write m equals 3/8. And then we write our y-intercept. You could write b equals, or I would prefer the coordinate as we are going to graph is the coordinate 0, 3/8. So, oops, no, I'm sorry, my bad. Fallible, of course. Okay, I was correcting my error and I had to erase all of that, but if you see here, our slope is 3/8 when we solve, and our y-intercept was 0 and -2. Correct. Okay, so now in terms of graphing, we start off with our y-intercept. First point that we have is 0, -2. And then the next point that to get the next point, we use our slope of a rise of 3 and run of 8. So we start here, and we go up 1, 2, 3, and go over 1, 2, 3, 4, 5, 6, 7, 8. So that point would be right here. We need 2 points to determine a line. If we only have 1 point, we can draw an infinite amount of lines through 1 point, but 2 points, we can only draw 1 line, of course, a straight line. We could draw a bunch of curvy lines, but we're just dealing with straight lines, so there we are. Okay, next we have give a line through this point with the slope of this, find the equation in standard form. Well, standard form again is ax plus by equals c. However, they give us a slope and a coordinate. Well, if they give us a slope, we know something about slope-intercept form. So first, even though we want to get ultimately standard form, we first are going to be in slope-intercept form because we're given the slope of 5. So I plug 5 in for m, and then we're given the coordinate x, the coordinate negative 10, 4. The x value of the coordinate is negative 10, and the y value is 4. Remember, y and x are the x and y of the graph, and they're related by multiplying the x value by 5 plus the y-intercept, which we don't know yet, in order to get our y value. In any case, we can plug it in and then get b. Note, you may use point-slope form. I haven't showed it here, but I believe it's in the book. If you like point-slope, you can try that. We can go over that together later if we get time. So, multiply those. We're solving for b to find the y-intercept. We add over, we get b equal to 54. So therefore, with the slope and y-intercept, the equation of the line is y equals 5x plus 54. Now that we have the y-intercept form, we want to get into standard form, which is, go ahead and write it here. Standard form again is ax plus by equals c, where a, b, and c are integers. So we look back at our inequality, or our equation. What do we have to do here? X is the only term that is not in the right spot, so we have to move x to the other side, which would be subtracting 5x. So in terms of getting into standard form, we want to move the 5x term over as I indicated, and we subtract it over. So we subtract 5x, and then we have plus y equals 54. Now note, all a, b, and c are all integers. Even though a is not positive, I'm fine with you keeping it as negative. Okay, turning to the next page, given 2 points, find the slope-intercept form. We need 2 things, the slope and the y-intercept. We're given 2 points, we can find the slope. We can't find the y-intercept from this, but we can find the slope. Algebraically, if you recall, the formula to find slope is the difference of the y's, which would be how much we rise or run, or rise either up or down, and then the difference of the x's is how much we change in terms of the x's. So, applying it to this problem, you can write either one as x1, y1, and either one as x2, y2. I'm just going to simply go in order. Okay, so we have the slope formula, y2 minus y1 over x2 minus x1, and we have x sub 1, y sub 1, x sub 2, y sub 2. Now we simply plug in. So for y sub 2 equals negative 3. So I have negative 3 minus y sub 1, which is negative 1, put in parentheses, divided by x sub 2, which is 1/3, minus x sub 1, which is 2. So first, in terms of simplifying, I'm going to make this m equals negative 3 plus 1 over 1/3 minus 2. I could have combined those, but if you look, we have a fraction within a fraction, which is complex fractions. We multiply by the least common denominator of the smaller fractions, which is 3. All the other denominators of the small fractions are 1. So we multiply the top and bottom of the large fraction by 3 over 3. Note, if you want to combine these by getting like denominators, simplify this and multiply by the reciprocal, you could do that. Note, if these are all whole numbers, this is much easier. In any case, when we simplify, m equals, we distribute the 3 into both. It's like parentheses, so we have negative 9 plus 3 divided by 3 distributed in there. It's in the numerator, so that cancels to be 1 minus 6. Okay, now we simplify, starting to run out of room. You have m equals negative 9 plus 3 is negative 6 divided by 1 minus 6 is negative 5, so that will turn into positive 6 over 5 is our slope. Okay, now, again, I apologize, I ran out of room. I'll just continue below. We have a slope of 5, 6. We plug it into
slope-intercept form. So I have y equals 6 over 5x plus b. Now remember, we need one coordinate, so we look up here, we need one of these coordinates, plug in for x and y. Well, you could do either of them. This one's easier, 2 for x and negative 1 for y. So we have 2 for x, for 6/5 is our slope, 2 for x. Okay, y equals negative 1, I plug that in for y. And now we simplify. I have negative 1 equals 12 over 5 plus b, that's 6/5 times 2. And now I subtract over, so I have negative 12/5 plus negative 1. And now I want to change negative 1 into same denominator as 5, so that would be negative 5 over negative 5. We add those together will give us negative 17 over 5 equals b. So I have a slope of 6/5 and a y-intercept of negative 7/15. So y equals, we rewrite with the slope minus the y-intercept. Hopefully I didn't make any errors. If I did, you get the idea of that. Okay, the second goal is determining the equations of circles in standard form. Circles, when graphed on the xy coordinate plane, we use this standard form. That's kind of like the y equals mx plus b for circles. HK is the center of the circle, and R is the radius of the circle. So that if we have the center and the radius, which are obviously very important parts of the circle, we can get a very nice algebraic form of the circle. So first question you have here is they give you the center, which is negative 7, 4, and the radius of 8. So if we relate it back to our formula, this is the coordinate h comma k, and this is r. That's supposed to be an r. So we simply plug it into the formula. X minus h in this case is negative 7 squared, plus y minus k, which is 4, didn't put parentheses around it since it's simply positive, you could if you wanted to, squared equals the radius squared. Note, I just plugged in h, k, and r. And then we simplify. X, opposite of a negative, is a positive, squared, plus y minus 4 squared equals 8 squared is 64. And that is your standard form. We don't FOIL or solve for x or solve for y. We keep it in that form because that form has hk and the radius. Of course, not exactly, but we can easily get it from that. Now, going back, just a quick back note. Where does that formula come from? We'll talk about more, but really it comes from Pythagorean theorem, because if we draw a triangle within a circle, a radius ends up being the hypotenuse of the triangle, and we do a squared plus b squared equals c squared. That's where that comes from, but we'll talk more about that later if time permitting. Okay, moving to the back page. First off, there are two formulas that if you did not take geometry, you may have some challenges with, or you may have not seen before, but I think you have, because actually we had this on the pre-assessment test way back in August. So the distance formula, and that distance formula actually comes from Pythagorean theorem as well. We'll talk more about it. But it just as you see, you have x2s, x1s, y2s, y1s. Those are for 2 points, x1, y1. Okay, so x1, y1, and x2, y2. Plugged in this formula will give you the distance between 2 points. So if we graph 2 points, if you look down at the bottom right of the video, if you graph 2 points anywhere, if you want to find the distance between them, we can use the distance formula. Okay, if we want to find the midpoint of a coordinate, then we do the average of the x's and the average of the y's, just like we do on a number line, but since it's just not one dimension, it's 2 dimensions, we do it for both the x's and the y's. Now, how is that relevant? These problems are a little more challenging, but we'll see that we'll have to use a midpoint formula and the distance formula, and they're really not too bad. Okay, so write the standard form of an equation given the endpoints of the diameter is 0, 0, and 12, 16. Note, the diameter is the a chord that goes through the center of the circle. So if and a chord is endpoints around the circle, 0, 0, and then 12, 16 is somewhere out here. It doesn't have to be exact. Note, if we connect those, that's the diameter of the circle. Now, I'm not going to draw a very accurate circle. We don't have to. We just have to see this visually to help us figure out what to do algebraically. Now, the two pieces of information we need to know, and remember, what we're trying to do is get standard form of the circle, which means we need the center and we need the radius. So the length of the radius, which is what the radius is. So we need to figure out what the center is. Well, the coordinate that we have here is 0, 0, and this one, just to make sure, is 12, 16. So this is 12, 16, and now we need to find the radius. Well, if we look at this diagram right here, this is the endpoints of a segment and this is the midpoint. So if we have these two endpoints and we want to find the center of the circle, let's find that first. I may have said radius before. I meant to say we want to find the center first if I misspoke, fallible as I am. We want to use the midpoint formula. Well, the midpoint formula again is right here. So I will zoom out so we can see this at the same time. So to find the center, h comma k, that's the same as the x comma y, in this case it's h comma k, equals, parenthesis, the x sub 1, which for this x value is 0, really doesn't matter what order we go in, plus the y value, or the x value of the second coordinate, which would be 12. If we do 0 plus 12 or 12 plus 0, it's the same thing. Divide by 2, because it's the average of the x values. It's also the average of the y values. The y values are 0 and 16. We divide by 2, and h comma k. Alright, we have 0 plus 12 divided by 2 is 6, and then 16 divided by 2 is 8. So there's our center, h comma k. Now we got to get the length of the radius. So if we look here, the radius is from the center to one of the endpoints. So we need to figure out what the length of this segment is. Well, first we know what that coordinate is now. The coordinate is 6, 8. So let's write that in here. 6, 8. And if we want to find the length of this segment, in either direction it's the same, it is the distance between these 2 points. So we're going to use these 2 coordinates or these 2 coordinates to find the distance using the distance formula. Now, for the challenging aspect of the distance formula, I don't think they're always going to give you 0, 0. If you use 0, 0, it might be a little easier than using 12, 16. But I'm going to use 12, 16 in the interest of doing coordinates with non-zero for x and y values. Okay, so the distance formula equals the square root of x sub 2, which is, I'm going to label this as x sub 2, y sub 2, and this is x sub 1, y sub 1. X sub 2 is the x value of the second coordinate, which is 12, minus x sub 1, which is 6, square it, plus y sub 2, which is 16, minus 8 squared. Note, there is the formula again right up here. X2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's what we have right there. And now we want to simplify. So d equals, now we can change d. What does d mean again? It means the radius of the circle. So let's represent what d really means, the distance between these 2 points. In this case, it's the radius. The square root of 12 minus 6 is 6 squared, plus 16 minus 8 is 8 squared. R equals, that would be 36 plus 64, and then r equals the square root of 100, and then r equals 10. We don't do plus or minus 10 because radius is simply positive. Even if we plugged in a negative, we're squaring it into the standard form. So it turned positive anyways. Okay, so standard form is x minus h. H was 6 again from the center, plus y minus k, which is 8, squared equals r squared. R is 10, so squared would be 100, and there's your standard form of the circle.